All right, Algebra 1B students, welcome to part 1 of lesson 9.1, the very beginning of chapter 9. We're going to be talking about quadratic graphs, like we already got a little bit of an introduction to in our classwork today. We're going to look at quadratic graphs and their properties. And we're going to start by just reviewing what a quadratic equation is and what one looks like. Okay, so remember from chapter 8 that a polynomial of degree 2 like this one, negative 16x squared plus 64 is called a quadratic polynomial. So degree 2 means a quadratic. And we are going to use quadratic polynomials to define a quadratic function like the one in the solver, which we did not do. Okay, so a quadratic function, as we can see right down here, quadratic function is a type of non-linear function that models certain situations where the rate of change is not constant. Okay? A quadratic function looks a lot like one of those, negative 16x squared plus 64, but it is a function, so there's a y equals involved there. Okay? A y equals, or in f of x equals, which you'll see in just a moment. The graph of a quadratic function is a symmetric curve with a highest or lowest point corresponding to a maximum or minimum value. And that's kind of our job for today, is to figure out our maximum and minimum values, the line of symmetry, and so on of these quadratic graphs. Okay? So a little bit of notes there, a little bit more notes right down here. A quadratic function is a function that can be written in this form. Y equals some number times x squared plus some number times x plus some number times 0, as long as this number here, a, is not 0. B and c can be 0, but a cannot be 0. That is called the standard form of a quadratic function, right? Because we go from exponent equals 2, exponent equals 1 to exponent being none in our C, obviously, left to right. Here's a couple examples. 3x squared, your a value there is 3. B and C are both 0. Here I have x squared plus 9. My a value is 1. And here a is 1, C is 9, B is 0. And here I got x squared minus x minus 2. A value is 1, B value is negative 1, C value is negative 2. So you can see that those are all of this form right here. But sometimes B and C are 0. The simplest quadratic function is just x squared. That's it. Just x squared. The graph of a quadratic function is a U-shaped curve called a parabola. A parabola, please put in your notes, is the graph of a quadratic function. Okay? And then they show you over to the right the parabola of the equation y equals x squared. Here it is, right here. Right over here. Okay. You can fold this parabola and every parabola so that the two sides match exactly, because both go on forever, upwards or downwards. This property is called symmetry, right? It's symmetric because we can fold it over onto itself. The fold, or the line that divides the parabola into two matching halves, is called the axis of symmetry. So axis of symmetry is the fold or line that divides the parabola in half. And I have marked it for you with this blue dashed line right there. That is the axis of symmetry. Okay? Now before we go on, I want to connect this to a table of values that we were doing in our classwork just today. So if we notice 0, 0 is here, 1, 1 is here, 2, 4 would be up there, and 3, 9 would be up and off the graph. Now, the other thing that I want to point out here is that if you look at the right side of the graph and the left side of the graph, you should see the symmetry happening. And it should be very easy for you to figure out where more points are if you know, for instance, these three. Okay? You know these three, and we can see that if we just pop across that blue line one space, we get right there. There's another point. We do the same thing up here. We pop across two spaces. There's another point. Okay, so we'll look at that more in detail in just a second, but be aware that that is coming. So there's a whole bunch of vocabulary about quadratic functions, and quadratic equations, and their graphs. We have just a little bit more things to add to our notes, and then we will start doing some example problems. Okay? First word that we're going to have to identify, really, is the vertex. The highest or lowest point of a parabola is its vertex. So highest point obviously would mean it comes up and goes back down. And the vertex would be here. Lowest point would mean it goes down and then comes back up. Its vertex would be here. And those are vertexes. They are the top or bottom of the parabola. And it lies on the axis of symmetry, right? Because this would be my axis of symmetry, and this would be my axis of symmetry here. Okay. Now, the way you can tell if it's going to be the top or bottom of the parabola, i.e. a maximum or minimum, is if your a value is positive or negative. Remember that a is the one that comes right in front of the x squared. If that number in front of the x squared is positive, if it's positive, that means it's going to look something like this. It's going to be this one over here. The parabola opens up like a U. I'm going to write that down here. This one's like a U. This one over here is the opposite. If A is negative, that's that number in front of the x squared. If that's negative, parabola opens downward like an N. Okay? Like an N. Opens downward. When you have one that opens upward, the vertex is the minimum point. If it opens downward, it's a maximum point. Okay, so there's a little more vocabulary. Vertex, minimum, maximum. Please take the time to get that in your notes. And we will look at an example problem of what you'll be asked to do in your homework assignment, your practice problem set tomorrow. Okay. The type of problem you'll see in your homework is relatively simple. They're just asking you to find what are the coordinates of the vertex of each graph, and is it a minimum or a maximum? Okay. Now, coordinates means something that looks like this. An x number and a y number in parentheses with a comma. An x tells you how far left and right you have to go. Y tells you how far up and down you need to go. So, in letter A here, my vertex, I believe, has an x value of 0 because I am not going left or right at all to get to that point. It has a y value of 3. That's the coordinates of my vertex. So I'll say vertex 0, 3. Is it a minimum or a maximum? Well, my parabola opens downward, so this is a maximum. Now I'd like you to do letter B. Identify the coordinates x and y of the vertex. Tell me if it is a maximum or a minimum. All right, pause the video, take a look at that, and come back. We'll show the answer and do one more quick example problem. All right, your answer here, vertex should be 1 in the x, down 1 in the y, negative 1 in the y, and that is most definitely a minimum. Do you have questions about that? please make a note to ask me in class tomorrow. Let's go on and look at the only other thing I'm going to ask you to do in tomorrow's practice problem set, which is actually graph these quadratic functions and do it rather quickly. So, if we want to graph for example, this equation here, y equals 1/3 x squared. The first thing that I need to do is try to find the vertex point. Now, the wonderful news for us is right here. For graphs of functions where it's just ax squared, no plus x's, no plus numbers, the vertex is at the origin. So what does the origin mean again? That is 0, 0. Okay, so if it's ever just some number x squared, your vertex is at 0, 0 every single time, including right down there. Okay? 0, 0. The axis of symmetry is the y-axis, or x equals 0, which I'll show you in just a second. So because I know that this function is just some number times x squared, I know my vertex is at 0, 0. Vertex is at 0, 0. And I can check that out, because if I put 0 in for x, 0 squared is 0, times 1/3 is still 0. So 0, 0. Now, your book's table of values jumps up to 3 already. The reason they do that is because right here, you'll notice there is a very small 3, because that says 1/3 right there. So if it's 1/3, jump up by 3s. If it's 1/2, jump up by 2s, and so on and so on and so on. Okay? So the next one they go to is 3. If you put 3 in for x, 3 squared is 9. 1/3 times 9 is 3. So I'm now at 3, 3. So I go 3, which in this case is just one tick mark on this graph, and up 3, right there. Okay. Then they go to 6. They do 6 times 6 is 36, times 1/3 is 12. So it's 6 and then 12. 6 and then 12 is right here on that graph. And then this is where our reflection comes in very handy. Because we know the vertex is here, which means my line of symmetry is right there. So all I'm going to do to find some other points on this graph and see what happens on the other side is just reflect. Straight across, new point right there. Straight across, new point right there. I connect them like a U, and I'm done. Alright, so find your vertex. Hopefully, sometimes it will be 0, 0. That will be nice and easy. Find a couple more points and reflect them across to find even more, and then make your U or your N, depending on if it's positive or negative. The only other thing I need you to do now is graph this function for me. Y equals negative 3 x squared. Negative 3 times x squared. And then tell me what are the domain and range. We can deal with all of that tomorrow. Let's just get the graphing down for right now. Because this is an a times x squared, some number times x squared, again, your vertex is going to be here at 0, 0. Pause the video, graph that function, and come back, and I'll show you what it should look like. Okay, now, if I go to 1, I'm down at negative 3. Negative 1, same way I reflect it across. If I go up to 2, I am at negative 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 and 12 are off the graph. So I'm going to go down very, very steeply, like this, and like that. There's the graph of that function. Very, very steep if you're counting only by ones. Okay. If you have questions about graphing quadratics, we'll get more practice tomorrow. That's all I have for you right now. Have a wonderful night.